I'm surprised to see you guys here.
We're Blue Fire Productions and we're here to interview you.
What do you want to talk to me about?
We want to talk about your work with supercomputers and the future.
Great then, follow me.
My name is Gary Strand, and I'm a software engineer here at the National Center for Atmospheric Research in Boulder, Colorado. I've worked here since I was in college, starting as a student assistant back in 1986. So just last Thursday I finished 25 years working here. I went to CU, the University of Colorado here in Boulder. I primarily studied physics, believe it or not. I also studied computer science, computer languages. I also took classes in psychology and political science and economics and electrical engineering. I kind of took a bunch of different classes. Well, I started as a very young child, younger than you guys. I've always been interested in science and the weather. Even when I was very little, I had one of these wind vanes and a thermometer and stuff like that, and would take observations and make note of when it rained and things like that. And as I got to college, I realized, this would be, I had visited NCAR when I was a kid, I'm quite certain, because my family grew up in this area. And as I got older, I realized NCAR would be a really nice place to work. I had the skills in the classes in high school and college to help me. CCE stands for the Intergovernmental Panel on Climate Change, and that is an international organization that was set up in 1988 to look at the climate system of our planet. And what they do, among other things, is they issue periodic assessments of the state of the climate system, and my job is to convert that data into a format that scientists all over the world can use, write scientific papers that are then included in these IPCC assessments. So that's been my job for about the last 18 months or so, and will continue for probably another year. One of the ways I get to use creativity in my job is exemplified by this book here, which is one of the standard textbooks for people that want to do and to learn about how to do climate modeling. It's called An Introduction to Three-Dimensional Climate Modeling. And it was written by my primary boss, Dr. Warren Washington, who is one of the most internationally recognized and respected climate scientists in the world. And this is a second edition of a book that he wrote in the mid-1980s. And he asked me to develop a new cover for it, as you can see here. And so what I was able to do was to kind of indulge my creative side. And what this shows is a representation of how climate models have gotten more complicated over time. So basically, here you can see these blocks are large and chunky, and it doesn't look much like the Earth. This is what climate models were like in the early 1970s. And down in this is what climate models are like today. You can see something that looks very much like you would see on a globe or something like that. And so what this emphasizes is, as we've learned more and more about the climate system, and as supercomputers have become more powerful, we're able to represent the Earth in a much more realistic fashion than we used to do 20 or 30 years ago. An idea of the amount of data that I deal with. Everybody's familiar with the little flash drive. People use them to transport documents and worksheets and things like that from one computer to another. You probably use one in your classwork, I'm sure. And what this is a standard little flash drive. You can pick this up at King Soopers or Save a Billion places for a few dollars. And so this one has a capacity of 8 gigabytes, which holds a lot of material. You could put many books on here, lots and lots of digital pictures. But what I did recently is I took a look at how much data we have from our climate models. And if this holds 8 gigabytes, you would need almost 400,000 of these to store all the data that we have currently as output from our climate models. The interesting thing is, if you line up this particular kind from end to end to end, that's about a 14-mile long string of these things. So we're talking a lot of data. This is 8 gigabytes. What I'm talking about is 3 petabytes, which is, to work your way back down the scale, is 3,000 terabytes or 3 million gigabytes of data. The idea is that as scientists look over the output from these different climate models, they can get a good to somewhat good idea of what the changes that are occurring in the climate system could lead to in the future. For example, not only does it get warmer, but precipitation patterns may change, so we may have to farm in different areas. Places where we think now would be a good place for a solar plant or a solar power facility may get cloudier in the future. Changes in heat waves, cold events. Basically, what these climate models are trying to do is not tell us exactly what the future will be like, but something about what the future may be like if we continue doing what we're doing today by burning fossil fuels and emitting the pollution into the atmosphere.